All right, here we go. 3.2, round 2. Tried it the first time, didn't work. This time's going to work good. So, side, side, side. We're talking about congruence of triangles. I'm proving that triangle MNP is congruent to triangle QRS. All I need is for all three sides to be congruent to each other, and I'm done. The minimum requirements is side, side, side. There's 5 different options, one of which is side, side, side. So if you ever see the 3 sides are congruent, you know every bit of that triangle is also congruent. Side, side, side is the first one. Here's an example. If I give you EF and GH are congruent, you need to mark it on the diagram. Here's EF and GH marked. Now I tell you the reason for that is given. FG and HE are congruent. Mark it on the diagram. We're going to use 2 hash marks because I used the first set for the first pair of congruent areas. And then I say the reason for that is given. Now GE is congruent to GE. Right here. Why would I make this statement? What's the reason behind it? Reflexive property. You guys need to mark it on the diagram and give the reason for it. Very, very important that you remember these reasons and you can give them to me for proofs. Because it's coming. This chapter is all about proofs. Being able to go step for step and tell me why things are the way they are. So now EFG and GHE are triangles. I start with E. Here's E. I go to F. I go along the single dash mark. So I start with G and go along the single dash mark. You have to go in the same order, corresponding order. Next one, side angle side. If I have a side and the angle in between them specifically has to be the angle in between the 2 sides, then I know that PQS triangle is congruent to WXY triangle. Okay, that's called side angle side. Again, minimum requirement. If that's all I can find, then I still know that all the rest of the pieces are also congruent. So I tell you that they're parallel. You need to mark it on the diagram. Reason for it? Given. Now AC and AC, that's not given to me, but AC is congruent to AC. I'm going to mark it on the diagram. Why would that be equal to itself? Reflexive. You got to be able to use those. Reflexive and transitive are really important. Now, AB is congruent to DC. That came from the given, but we still have to mark it on the diagram and tell me that it was given. Now, this BAC and DCA, I would suggest if it's given to you as a statement, you mark it on the diagram. It will help you see it. Now look at this. This angle is congruent to that angle. Why would this angle here be congruent to that angle there? Let's see. They're inside the parallels, makes them interior. They're on opposite sides. That means they're alternate, so we call them alternate interior angles. Now that I have a side, and the angle in between them, right here, side, and the angle in between. Notice I start with the side that's congruent. I travel along the triangle to the angle that's congruent, and I travel along the triangle to the side that's congruent. That's how I know it's side, angle, side. And so I put that as my reason, and I know if I have this, then I also now can say that these sides are congruent. I can say that because I have side, angle, side. Every piece of that triangle is now congruent. Isn't that kind of cool? With just 3 pieces, I know everything's congruent. All right, essential questions. Feel free to answer this on your own. Pause the video if you need to. I'm moving on. These 2 triangles are not congruent. Notice how it's angle, side, side. The angle is not in between the 2 sides. And when that happens, I can now swing this S side, this side with the 2 hash marks. I can swing it all the way out here. The angle never changed, but sure doesn't look the same. That's why we say there's no donkeys in geometry. You'll never see me use angle, side, side. Ever, ever, ever. So if you think you've got congruence, you're wrong. No donkeys. No angle, side, side. Now, if it's a right angle, we don't call it angle, side, side. We call it hypotenuse leg. And we're going to talk about that right now. All right, so I have a 90-degree angle. That's an angle. Here's a side congruent, side congruent, side congruent, side congruent. But I don't call it angle, side, side. I call it hypotenuse leg. Remember, hypotenuse is a long word for the long side of a triangle, and the legs of a right triangle are the shorter sides. So if I have a 90-degree angle and a side and the hypotenuse, then I have a right congruent triangles. So right here, I give you an example. Oh, here we go. DC is perpendicular to AB. That goes in the first statement, and I say it's given. I draw it on the diagram, and it's given. Perpendicular means 90 degrees. Now my next statement is AC is congruent to BC. Mark it on the diagram, and then put it as given. Now where am I going to go from here? I've got 90 degrees, and I've got a hypotenuse. I need one of these legs to be congruent. Which one's it going to be? I don't know which one I can use, but I know using reflexive property that DC is congruent to DC. So I can say reflexive property makes it equal to itself. Now, do I have a 90-degree angle? Yes. Do I have the hypotenuse is congruent? Yes. Do I have a leg congruent? Yes. Then I can say the whole triangles are congruent because of hypotenuse leg. And I'm done. That is a proof for the fact that triangle ADC is congruent to triangle BDC. All right, no time for questions, and you can't talk to me anyways. Potential question. Go ahead and pause the video, answer this question on your own, give it your best go. Angle, side, angle. Now, remember how we had side, angle, side? It was a side with the angle pinched. Now I have an angle, and the side is in between those two angles. So it has to go angle, sorry, somebody came in. Angle, side, angle. We have to travel along the triangle, and we get angle, side, angle. Now we're going to show an example of what this looks like. These are your 5 methods of proving they're congruent. So my first statement, probably going to be from a given. All right? Always is the given. Don't forget that. Always is the given. I mark it on the diagram. Those parallels are right there. Now I'm telling you that angle 1 and 2 are congruent and 3 and 4 are congruent. Mark it on the diagram. You're going to hear me say that so much. Mark it. I told you that. Put it on there. Now, why would 1 and 2 be equal? Looks like they're inside the parallels and alternate sides. So I would say alternate interior angles. Does that also work for 3 and 4? Yes, it does. Just a different set of parallels. Now I say reflexive property right here. I give you the reason is reflexive property. That's a hint something is equal to itself. The only thing on there that copies that's on top of itself is HJ. So I say HJ is congruent to HJ, and that gives me an angle and a side and an angle. And I say we're done. I hope everyone can see right here. Red, dash mark, blue. Blue, dash mark, red. When I say GHJ, GHJ, I travel from G to the red angle, which is H. And then I travel to the blue angle, which is J. So when I start from I have to go to J, which is the red angle, and then to H, which is the blue angle. I have to go in the right order. All right. Now, angle, side, angle, side. This one is allowed. Angle, side, no. Angle, side, yes. All right. Now, that means I have an angle. I travel along the triangle to the next angle, and then I travel along until I hit the side. That's angle, side, angle, side. Angle, side, angle, side. This is our next method and our last one. Angle, side. Oh, this one's got some craziness going on here. Notice how I have the 2 top angles are congruent, and these 2 bottom angles are congruent right here, these 2 bottom ones. That's given to me. So I'm going to put that as my given and as my given. Now, what I need is a side of some sort, and it has to go angle, side. So if I come up here and I draw a blue triangle right there, I've got this angle and this angle. I need a side. So either going to be this side up here or this side down here. All right, now I'm going to do it in green with this triangle. I've got this angle and this angle. I need a side, either this one or this one. Now, there's no way for me to tell that QR and PS are congruent. They're not on top of each other. There's no information given to me. But this QS is congruent to itself. So we can say QS is congruent to QS, and we can say it's because it's reflexive. Now I have angle, side. So I've got my triangles are congruent. The purpose of this is because if I can prove they're congruent, now I know that RQ and TS are congruent because the whole triangles are congruent. Every corresponding part, remember we talked about that? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. It's huge for today. All right, so example, we have enough information in here to prove the triangles are congruent. I've got parallels, so I can say angles are congruent to each other, right? I could say right here, the blue and the green angles are congruent, but that's just two sets of angles. I would need to have the side in between them. It's reflexive. Ta-da! I just got angle side angle just by looking at it. I know I didn't do that really quickly, but that's part of being absent. You got to just deal with the quick examples. All right, so here I have a side side. I either need to show that the third side is congruent to get side side side, or I have to show that the angle is congruent to get side angle side. Those are my only options. But I really don't have any parallel lines. I don't have anything told to me that they're parallel or congruent or midpoints. So I really don't have enough information to prove it. Now, if I told you that point V here was the midpoint of EJ, then I could get congruence. I could get side, side, side. But I didn't tell you that. I haven't given you enough information to prove it. So no, there is not enough information. Here we go. I've got angle, angle, and a side and a side. So either I need angle, angle, side, or I need angle, side, angle. So if I travel from this angle along the triangle to this side, I got to keep going. So I need this angle to be congruent. So is this angle congruent to this angle? You're darn right it is. A vertical angle. So I can say because of vertical angles, or VA, I've got here and here. That gives me angle side angle. So it tells you to tell which congruence postulate you would use. Answer's angle side angle. State the congruence. This is a big one. SVR. So if I said triangle SVR, it's a terrible V, but you'll get it, is congruent to triangle. Now I start with S. What corresponding part of S is there? T. Good, so I start with T. V corresponds to V, and R corresponds to U. So SV, let me fix that V a little bit, SVR is congruent to TVU. Erase this. Going on. Here we've got angle and angle. So I either need the side in between them to be equal, right, for angle side angle, or I need a side next to it to be equal for angle angle side. I don't have any information like that, so I cannot prove these triangles are congruent. Ooh, parallel lines. I like parallel lines because they give us a lot of information. Here I have a side, and I have an angle because of alternate interior angles. Now, I either need to have side angle side. Oh, look at that. AC. It's congruent to itself by reflexive. So now I have side angle side, and I would have to write down the triangle congruence. Triangle AGC. Let's just do with AGC. Angle A is here, and that corresponds to triangle C. A corresponds to C. G up here corresponds to B over here, so we put B. And then C corresponds to A, so I put there. Sorry you can't see that last part. I'm going to erase all of this. Going on to the next example. How much time do I have left? Okay, got about 2 more minutes. So any questions? All right, so here's another one. Decide whether there's enough information. I've got parallel lines and a side. I can show that this angle here is congruent to this angle here by alternate interior angles. I can show that SQ is congruent to itself because of reflexive property. Now I have side angle side. And I would write the congruence using the right points. So I'd say triangle, let's just say I do R, supposed to be Q, R, Q, S is congruent to R corresponds to P over here. So I'd start with P, triangle P. And then I went to Q. Q is a blue angle. And that corresponds to S over here, and then S corresponds to Q over here. So we say PSQ. Hopefully you got that off my bad handwriting. I'm writing with my finger on a computer screen. So give me a break. So I only have a little bit left. Here I have this side here is good. It's reflexive. So I say side, angle, side, and I'm done. I have to fill out the congruence. Go ahead and fill out the summary page. We might do a foldable in class if I have time. But there's your notes. Get your notes done, get your homework done, and good luck.